Building classical machine learning models with Python. Today, Maya and her robo-friend Momo are going to explore the fascinating world of machine learning. Unlike traditional programming, where people write rules step by step, machine learning allows computers to learn patterns from data and make predictions on their own. It's like teaching a computer by showing examples instead of giving detailed instructions. Machine learning is all around us. When your email automatically sends junk to the spam folder, that's ML. When apps predict tomorrow's stock prices or suggest your favorite songs, that's ML. Even robots use it to navigate paths safely. These models act like the brains of technology, helping machines analyze information, find patterns, and make smart decisions. One of the simplest and most classical models is linear regression. Imagine you want to estimate house prices based on their size. Linear regression draws the best possible line through your data points. The slope tells us how much the price increases per square meter, and the intercept shows the starting value. This model is simple, but very powerful for predictions. Another classical model is the decision tree. It makes predictions using a series of if-then questions. For example, did the student study more than 3 hours? If yes, predict pass. If no, predict fail. Just like people use logic step by step, decision trees use branching paths to reach conclusions. No matter which model we choose, building ML always follows a pipeline. First, collect data from the real world. Then, clean it to remove mistakes or missing values. Next, split the data into training and testing sets. Train the model so it can learn, then test it to measure accuracy. Finally, deploy it to solve real problems. Python makes this process much easier with powerful libraries. Scikit-learn is great for classical models like regression and decision trees. SCIPY adds extra math and statistics tools. And when we move to more advanced projects, TensorFlow and PyTorch let us build neural networks and deep learning models. These tools allow anyone, from beginners to experts, to bring ideas to life. Classical machine learning models are often faster, simpler, and easier to explain. They work really well when data is limited or when we need quick answers. Deep learning, on the other hand, shines when we have huge amounts of data and complex problems, like recognizing faces or translating languages. Both approaches are valuable, depending on the problem. Machine learning is transforming industries everywhere. In healthcare, it predicts diseases early. In finance, it detects fraud and risks. In retail, it personalizes recommendations. In education, it tailors lessons to each student. And in robotics, it allows machines to act intelligently in real time. The best part? You don't need thousands of lines of code. With Python, just a few lines can create and train a model.
That's why Python is the #1 choice for students, researchers, and developers who want to dive into machine learning. Maya has learned that classical ML models may be simple, but they are powerful, efficient, and easy to explain. And with Python, anyone can build models that learn from data and make smart predictions. This is just the beginning of her journey into the world of artificial intelligence.